Hello, my name is Ian Mauricio Ortiz Vargas. I have 24 years old. I studied at the Salesian College in Duitama from 1st grade through 11th grade. I was born in Sogamoso but always lived in Duitama. I'm technologist and industrial mechanical maintenance. I'm a student of mechanical engineering. This is my 10th semester. I arrived to Bogota in 2008. I would like to talk about the electrical energy storage, as this is a very important issue in our present because this can affect the future. This topic is important for me as it is a subject of which I am focusing on my career, and I hope you enjoy it.
The first one, the roles of electrical energy storage technologies and electric use. Characteristics of electricity. Two characteristics of electricity lead to issues in its use, and, and by the same token generate the market needs for EEEs. First, electricity is consumed at the same time as it is generated. The proper amount of electricity must always be provided to meet the varying demand. An imbalance between supply and demand will damage the stability and quality, voltage and frequency of the power supply, even when it does not lead to totally unsatisfied demand. The second characteristic is that the place where electricity is generated are usually located far from the location where it is consumed. Generators and consumers are connected through power grids and form a power system in function of the location and the quantities of power supply and demand. Much power flow may happen to be concentrated into a specific transmission line, and this may cause congestion, since power lines are always needed if a failure on a line occurs. Also, because lines are always needed, supplying electricity to mobile application is difficult. The following sections outlines the issues caused by these characteristics and the consequent role for EEE. Other topic is emerging needs for ease. There are two major emerging market needs for ease as a key technology: to utilize more renewable energy and less fossil fuel, and the future smart grid. More renewable energy, less fossil fuel. This is some topic very important. In grid areas, this increased ratio of renewable generation might cause several issues in the power grid. First, in power grid operation, the fluctuation in the output of renewable generation makes system frequency control difficult, and the frequency deviation becomes too wide. Systems operation can deteriorate. Conventionality frequency control is most managed by the output change capability of thermal generators. When used for this purpose, thermal generation are not operated at full capacity. but with some positive and negative output margin, which is used to adjust frequency, and this implies inefficient operation. With greater penetration of renewable generation, this output margin needs to be increased with which decreases the efficiency of thermal generation even more. Renewable generation units themselves in most cases only supply a negative margin. If EEs can mitigate the output fluctuation, the margins of thermal generators can be reduced and they can be operated at higher efficiency. Secondly, renewable energy output is undependable since it is affected by weather conditions. Some measures are available to cope with this. One is to increase the amount of renewable generation installed, provide overcapacity so that even with undependability, enough power can be secured. Another is to spread the installation of renewable generation over the wide area to take advantage of weather conditions changing from place to place and of smoothing effects expected from the complementary of wind and solar generators. These measures are possible only with large number of installation and extension of transmission networks. Mm, Other item important is smart grid use. EEs is expected to play an essential role in the future smart grid. Some relevant applications of EEs are described below. First, each installed consumer-side substation can control power flow and mitigate congestions, or maintain voltage and appropriate range. Secondly, EEs can support the electrification of existing equipment so as to integrate into the smart grid. Electric vehicles are a good example since there have been deployed in several regions, and some are for the potential of EVs as a mobile distribute energy resource to provide a load shifting function in a smart grid. EVs are expected to be not only a new load for electricity but a possible storage medium that could superpower to utilities when the electricity price is high. Now, types and features and energy storage systems. Classification of EEE systems. A widely used approach for classifying IIE's system is the determination according to the form of energy used. In the figure as shown, systems are classified into mechanical, electrochemical, chemical, electrical, and thermal energy storage systems. Hydrogen and synthetic gas natural gas are secondary energy carriers and can be used to store electrical energy via electrolysis of water to produce hydrogen and in additional step methane and if required. In fuel cells, electricity is generated by oxidizing hydrogen and methane. This combined electrolysis fuel cells process is an electrochemical. However, both gases are multiple purposes energy carriers. For example, electricity can be generated in a gas of a steam turbine. Consequently, they are classified as chemical energy storage systems. In the figure, thermal energy storage systems are included as well, although in most cases electricity is not the direct input to such storage systems, but with the help of thermal energy storage, the energy from renewable energy source can be buffered and thus electricity can be produced on demand. Examples are hot molten salts in concentrated solar power plants and the storage of heat in compressed air plants using an adiabatic processes. Now, the mechanical storage systems. The most common mechanical storage systems are pumped hydroelectric and power plants, pumped hydro storage, compressed air energy storage, and flywheel energy storage. Other is electrochemical storage systems. Excite various types of batteries are described. Most of them are technologically immature for practical use. First, 6 secondary batteries types are listed: lead, acid, NiCad, ion lead, metal iron, sodium sulfur, and sodium nickel chloride. Then flow to source or flow back. Other is the chemical energy storage. The chemical energy storage focuses on hydrogen and synthetic gas, natural gas, a secondary energy carrier, since this could have a significant impact on the storage of electrical energy in large quantities. The main purpose of such a chemical energy storage system is to use excess electricity to produce hydrogen via water electrolysis. Once hydrogen is produced, different ways are available for using it as an energy carrier, either as pure hydrogen or as SNG. Although the overall efficiency of hydrogen and SNG is low compared to the storage technologies such as ion lithium, chemical energy storage is the only concept which allows storage of large amounts of energy of the terawatt-hour range and for greater periods of time, even as seasonal storage. Well, this is my video. I hope you enjoy it.